Hello, everyone, and welcome back to Black Harbor's Advanced HARA series. I'm going to let Justin kick us off. Justin?
Yep. Hello again, everybody. Today we are going to be talking about cybersecurity goals and kind of how we think about them in the space of TARAs. So cybersecurity goals, they are defined as concept level cybersecurity requirements associated with one or more threat scenarios. So a lot of times when we're creating these TARAs, we're going to have a lot of different damage scenarios and threat scenarios. So out of those, we try to find kind of fixes for them, right? So requirements are going to be kind of the most detailed explanation on how we're going to try and not have those possible threats exist anymore. And then at the very top, we've got these actual concepts of things just like uh, wanting to make sure that we don't have attacks feasible remotely, perhaps, or we don't want PII to be able to be gotten by outside actors, things like that. And then the goals themselves are going to kind of align more somewhat directly to an actual threat or damage scenario. Well, not directly to the damage scenario, but the threat scenario, right, on how that damage scenario can actually come about. So we want to figure out what exactly an attacker might do to cause said damage scenario and figure out how to mitigate those threats. That's kind of what these goals are for. So all lower level requirements should be based on those cybersecurity goals. So of course, we don't want to have requirements that are just fluff. We don't want to have just kind of added complexity with no real value behind them. And we want the organization's support for those goals through the creation of policies based on top level cybersecurity goals. This kind of also falls under the concept as well, but there is kind of the uh, cultural and organizational support that is required. Because if you don't have a organization that wants to actually build up cybersecurity and focus on it, you won't be able to kind of get their final buy off on possibly adding cost and complexity for the sake of added security and safety. So the characteristics of these cybersecurity goals is going to be that they are necessary, complete, feasible, unambiguous, and avoid imprecise quantifiers. So if you look inside of the goal here on the right, you do see that there is a verification area as well. So when you say unambiguous and avoid imprecise quantifiers, we do want these goals to be measurable in a way, especially these requirements as well. But we want to say things kind of along the lines of, uh, so the concepts are going to say, for instance, you can't look at any PII, and then the goal will say uh, something along the lines of perhaps user groups are enforced strictly and elevation of privileges is impossible, right? So all of those phrases there kind of let you know uh, what exactly is going on, and you can test that then via a pen test or otherwise to kind of verify that that is the case. And of course, that it would also be necessary, right? And complete and feasible. And you can also see here kind of how it flows into the line of these taras. So when you create a tara, you start off with the item definition. Oftentimes you're handed not handed, but you would look at a boundary diagram for a feature or perhaps a whole vehicle or whatever it is you might be performing a tara on, then breaking that down to the assets you actually care about and their connections, and then the environment that it's in. Then you look at any of those critical interactions and assets to figure out where the attack surface really is and where attackers might be trying to get in at. And then, of course, trying to figure out here at the end those goals to try and mitigate those threats as much as possible. So how do you actually derive these security goals? So first you want to consider the context in which the TAR is being developed. So again, the item definition, the operational environment, and the security properties that must be maintained. So what this is really saying is, again, to really look at the scope of what it is that you are performing a TARA on, and then at the end, not creating goals that are going to be for things kind of outside of that actual scope and that boundary, So you wouldn't want to try and say that a cybersecurity goal is to have like backend server hardening for something that doesn't even have a connection to any servers, right? So you just want to make sure that it is in in fact going to be for that specific feature. Then the expected outcomes here. So cybersecurity claims to achieve the cybersecurity goal, and then the defined assets and interactions that must be protected. So again, we want to really point out what it is that you're trying to actually achieve with these goals, and you want to show the correlation to these TARAs and how the claim of performing these different types of kind of goals and requirements will let you mitigate those threats and not have those attacks be able to persist. So the why, the properties here, kind of helps us define some of the security attributes. So when we want to think about perhaps a certain attack path somebody might go down, we can look at a list of the assets and kind of understand what kind of attacks might be feasible there. So if a ECU has some sort of login or something like that, we might have some authorization that is needed to do certain actions. So if there's any type of privilege escalation, that'd be something we could look at there and create a goal for that to say no privilege escalation, right? And then further create requirements that go into that in more detail. And then perhaps we have availability, right? That's going to be pretty much an issue for every ECU and pretty much any feature on the car. You want it to be available when it should be. So, of course, that's going to be something that matters there. So again, it's going to be looking at the exact feature, the components of it, kind of what matters the most in certain areas, and then seeing again how an attacker might go through that and figuring out what that path is and how it aligns here to kind of give you an idea of how to protect against it as well. And this kind of goes in line of the whole organizational thought and backing that's required here. So the planning and the verification includes reviews and analysis activities, not just testing. What this is really saying is that cybersecurity is not just a at the end see if we have it type of a thing, right? You want to make sure that the cybersecurity kind of goals and plans and thoughts and all that are there at the beginning. So you want to have that kind of beginning knowledge of we want cybersecurity, we want X level of protection, and then as you develop it, you can kind of create these uh, kind of base level and before product creation type taras to where it's kind of just in your head, you're kind of just thinking of these things right before any real product is made or suppliers are asked to create ECUs before any of that really happens. You can try to come up with the kind of these worst case scenarios, create goals to mitigate those, and then figure out the requirements that would be needed to kind of meet that. So as you kind of get through that product development lifecycle, you get to kind of more and more integrated and difficult levels of testing. So in the beginning, when you just have some software, say an ECU just has some software, they could possibly send that out to you to where you just have some pins set up to give input and output and kind of just see kind of how things are interacting there. That's going to be the kind of easiest level of effort and testing there because again, there's not too much really going on, right? It's just going to be some sort of code that you can execute and kind of mess with to try and see where the holes are. And then the hardware, this is going to be kind of the next step. Perhaps at this point, you've asked the suppliers to make some ECU to adhere to your requirements. This is where you're now able to more fully test that specific ECU to make sure that it does indeed adhere to the requirements that you had sent out. And then, of course, also verify that those requirements worked, right? You may have told them to do X, Y, and Z, but this doesn't actually protect against what you were trying. That might just be the case. So that may be one of those instances where you would take that, look through it, kind of figure out where the holes were, and then update your requirements and ask the supplier to kind of update their end of stuff as well. And then system integration, once hopefully all of the software and hardware has kind of been figured out, fixed, and is good to go, you can get to actually adding all these ECUs together and having kind of a more base level vehicle, but not the entire vehicle, right? So there's going to be kind of the bucks or those testing boards. And here there's going to be a lot of kind of communication happening between the different hardwares and softwares. So again, this is just going to get more difficult in both the effort and testing areas. So harder to put together, harder to test on because there's just a lot going on. But of course, this is again where you would be testing to make sure that your goals are indeed being achieved. You'd be wanting to do some pen testing here, want to figure out if your requirements actually work now that everything is combined. And then lastly, you're going to take the system, actually add it into a vehicle, see if the real world scenario and situations are protected against with the goals that you had created, which at this point you would hope is true, because if it's not, there's going to be a lot more difficulty in iteratively testing, as you now have an entire vehicle to have to try and change around. Of course, possible, right? We have a lot of testing vehicles going around all the time, but it is a lot easier when you only have to make a couple at most, right? Or just switch out a couple components as changes are made rather than entire vehicles. So we've talked about kind of the entire vehicle here. Now we can kind of look at how to create these cybersecurity goals again. And well, we have talked about how we want to use the threat scenarios to develop cybersecurity goals. Some might kind of question, are we able to use HARA to establish cybersecurity goals? So this is going to be more along the lines of just safety. So safety and kind of the ratings given to vehicles for like their ASIL ratings, right? And their different components and features and all of that, that gives you a good understanding of kind of what areas you want to protect and what features you want to protect and kind of what actions, right, you want to try and protect or protect against, right? So this gives you kind of that base level understanding of where to look. But once you get there, it doesn't really give you an idea of how to do it or what exactly it is that needs to actually be given that extra protection. So it's kind of it's a good stepping stone to get you kind of into that idea and that brain space of here's where things are that are kind of problems and that need to be protected. But it doesn't look at anything that is very specific to cybersecurity in terms of PII and that type of like privilege escalation. Those types of things are not going to be necessarily pointed out in a HARA. So they are more just kind of pointers to show you where to look rather than kind of the end all be all for these goals. Useful, yes, but again, not everything you need. So can you think of some security goals that we can set for a headlamp control system, for instance? So this would be just in any vehicle, right? You're going to have headlights, of course. So what type of goals might you have for something like this? Well, one, we might want to say that the headlamp control must be available to driver at all times when the vehicle is powered on. So this is going to just be saying that availability, right? And kind of that CII triad is going to be something that is there for the vehicle. It's not going to have a lack of availability for this feature. And we want it to turn on only when initialized by reduced sun exposure or driver input. This is, again, in the CII triad, the integrity. So to protect against integrity, right, we don't want any outside user or unauthorized user to be able to perform an action that they shouldn't be. So again, this would be the driver or sun exposure being the only thing is able to actually actuate this feature in the system. Oh, and I guess the end here is going to be for if you guys have any thoughts of your own to kind of add on to this as to what type of different goals you might want to create for this. Another goal might be something where, if we're talking about the CIA triad, right? If we want to talk about like confidentiality, for instance, maybe we want the signals that are being sent to be encrypted so that nobody can get in there and send them themselves, which would be kind of both integrity and confidentiality. Or again, you could create some other goals that also fall in line with availability, to where rather than just being powered on, you want it to be as long as a key is detected inside the vehicle, or even when the vehicle isn't powered on or in accessory mode, but even just in the kind of waiting state, waiting to be turned on, right? Like when you unlock the car, it has that kind of limited power type time. So maybe in that section you want to also be able to turn on the headlamp. So all these different things kind of fall in line with both the features function, but also security goals and how they align with each other. But that is it for today. So thank you everybody for stopping by and listening, and I look forward to talking to you again.
Awesome. Thank you, Justin. Great job as always. Looking forward to having everyone keep following us. Chat soon.